Teaching aids are essential for making math fun and engaging for primary school students. They help kids learn by making abstract concepts more concrete. To enhance the learning experience and make complex concepts more accessible in mathematics, where logical reasoning and problem solving skills are pivotal. Within this assignment, you will see various construction of the following teaching aids for primary school mathematics: a circular geoboard, a rectangular geoboard, a set of Chinese Thakur-Ram, a fraction wheel, a set of volumetric measuring instrument, an attribute logic set, 1 meter triangle wheel, and mathematical balance, an innovative teaching aid for primary school mathematics. Each video shown was demonstrate how to construct a teaching aid for primary school mathematics for various grade levels.
Good morning, everyone. Here I'm having a circular geoboard which was constructed to teach concepts at 4 different levels in the primary school. First, I will begin with grade 1. Concept, we can teach plane shapes at grade 1 and it can be represented on the geoboard. For example, making a triangle. Using rubber bands, placing a rubber band on the pegs. And you can have the children do this activity and also counting the sides and the points. Next we are on bit 2. Now we can have the children use rubber bands on the pegs to represent fractions. Like this. We can have them show quarter. We can have them show half, 3/4, and also whole, using the geo. Alright, so we can have them represent fraction on the circular geoboard. We can have quarter, half, 3/4, and also a whole. Now we are on to grade 3. So we can have we can teach concepts such as position and directions. So we can have the children placing rubber band on the middle peg, the center, and to show clockwise and also anti-clockwise direction. So for grade 4, we can teach reflection. So here on the geoboard, I would have placed a rubber band, right, to make a triangle there, and you can also have the children reflecting it on the other side using 4 pegs and to show reflection. So we have a reflection, we have a triangle here and it's reflecting here, or they can do it here also, placing the rubber band on the pegs to show or to represent reflection. Alright, so this is how you can use the geoboard to teach 4 different concepts at 4 different levels. Thank you.
A rectangular geoboard is a hands-on math tool used for exploring geometry like areas, shapes, perimeters, fractions, transformation, and symmetries, etc. For grade 1, we can teach shapes. We can have the children make different shapes using rubber band on the geoboard. We can have them create like squares. They can create rectangle. They can create triangle. And also we can have them tell us how many sides each shape has. For grade 2, we can teach lengths. We can have them make a rectangle shape, one which is longer than one, and it could tell us the length of the shape. For grade 3, we can
do congruent shape. Now, congruent shapes are identical shapes. So we can have them create square and the next square. So these two are congruent because they are identical. We can have them create triangle. So these two shapes are congruent shapes. For grade 4, we can teach perimeter. We can compare the perimeter between these two shapes. Like, we can have them tell us what is the perimeter of the square and what is the perimeter of the triangle and compare them.
Having not known about the Chinese tangram before, this was a fun and interactive journey for me while creating this. Now, this composed of several pieces. When fit together, it forms a rectangle or square. Now, I will use this to teach fraction and area. I can ask pupils to rearrange the tangram pieces to form a shape. Now, we can discuss how each piece represents a fraction of a whole shape. Now I can also use this to teach symmetry. Now once my pupils are comfortable with the tangram pieces, we can explore symmetry by folding the tangram pieces to create symmetric shapes. Now I can also use this to create new shapes. I am talking, the first concept I spoke about was the grade 3 classroom, then the grade 4. Now I can even use this to create new shapes in the grade 1. I can challenge my pupils to use the pieces to create different shapes such as animals, even houses or abstract design. Now as they do this, I can also discuss the property of these shapes. Now, this was a eye opener for me, and that's about it.
Good morning. Today I will be demonstrating how to teach 2 grades using a fractional wheel. Here I have a fractional wheel. And for grade 1, first I would ask, you would be able to ask them, what do you think this is? And if they do not know, most likely they wouldn't. And you would tell them, well, this is a fractional wheel. And each section represents a part of a whole fraction or a whole in general. You can even explain to them that a cookie would be a whole until you start to eat part of it or you break part of it, or a pizza would be a whole and then you can cut it into slices. You can show the learners that when you turn the fractional wheel, this is a half, and when you continue to turn it, this will be a whole, and you can even show them that 2 halves make a whole, and 4 quarters, you can show them the quarters, 4 quarters can come together to make a whole. For your worksheet, you can give the learners a worksheet to color half of the cookie or half of a pizza or quarter of a pizza. When you have finished, when your lesson is completed, you can give them the activity so that you can reinforce fractions. For grade 4, you can remind the learners about fraction, because they would have learned it in the earlier grades. You can show them that this is a fractional wheel, and we can use the fractional wheel to learn equivalent of fraction. You can give them the opportunity to make their own fractional wheel and show them how we can use this fractional wheel to find fraction or to learn more about fractions. You can teach them that 2/8 is the same as a quarter, and even 4/8 is the same as a half. Because when we turn the fractional wheel here, we can see this is a half of this whole. And when you continue to turn it, you can see this is 5/8, 6/8, 7/8, and even when you turn it to the full, you can see this is a whole fraction, the whole circle. So you can take the fractional wheel and you can teach all different parts of fraction and also the equivalent. And this is how you can use a fractional wheel to teach 2 different grades fractions. Thank you.
I am Barbara Thakur-Ram, and today I am going to use this fraction wheel to teach grade 2 and grade 3 learners. First, for our grade 2 babies, our topic will be shading fractional parts. So here I have a whole pizza, and it is divided into 8 equal slices. And as we know, our babies, they are fond of pizza. So here we have 1/8 of the pizza, and we are going to use this fraction chart, the color code, to help the children to understand to shade fractional parts better. So we are going to move it to show 1/8. So here the children will know that they have to shade only 1 slice of the pizza. So here we have 2/8 of the pizza. And if we ask the children to shade 2/8 of the pizza, they will, as we move our color code, they will better understand that they have to shade only 2 slices of the pizza. And we go on here, we are showing 3/8 of the pizza. And if we ask the children to shade 3/8 of the pizza using this color code, they will be able to know that they have to shade only 3 slices of the pizza, and you can go on. In conclusion, we can say that the fraction wheel is a very good teaching aid in helping to teach some concept of fraction at the primary school level. Thank you.
So using the volumetric measuring instrument, it can be used to teach various concepts across grade 1 to 4. In grade 1, you can teach the concept more or less. Now, I have here 2 containers labeled A and the other container labeled B. Now I will ask them to look at the container carefully, to look at the liquid inside of the container, and I will ask them which container holds the most amount of water. So they will have to look at it and they will be able to say that, oh, that container A holds the most amount of water than container B. You can also ask them which container holds the least amount of water, and they will be able to say, okay, container B holds the least amount of water. For grade 2, you can teach the concept estimate. They will be able to estimate how many small cups using the non-standard units. So here I will be using the small glasses, and I will ask them to make an estimate as to how many small glasses will fill container A. So they will now make their estimate. Now after they would have finished written their answer, I will allow them to fill the container by themselves. So they will be able to fill the glasses and pour it in the container and count the amount of glasses that would fill the container. For grade 3, the concept can be taught for grade 3 they will be reading the scale, which is the metric units. So they will all read the metric units on the container. So they will look at each container and they will be able to see where the amount of water is, and then okay, they will be able to say that here the water is at half liter, and half liter is equivalent to 500 milliliters. So they will be reading the unit measurement. So they will be reading this container, and for the other container they will also look at the measurement here and they will also read it, and then they can also add the milliliters and be able to say how many milliliters both containers hold altogether. For grade 4, the concept is unit conversion. So that's where they will know how many milliliters is equal to 1 liter, and so here I have here a little chart showing 1 liter is equal to 1000 milliliters. And so when they look at the container here as well, they will be able to see, okay, this here is showing 1 liter, which is also equivalent to 1000 milliliter. 3/4 liter is equivalent to 750 milliliters. And half liter is equivalent to 500 milliliters. And 1/4 liter is equivalent to 250 milliliters. So now I will ask them like questions, like little problem solving questions now. Because they would have already know that 1 liter is equivalent to 1000 milliliter, I can ask how many 250 milliliter cups in one liter. So they will be able to say, okay, that 1 liter is equivalent to 1000 milliliters, and if you divide, that's where division comes in, 250 divided by 1000 milliliter, you will get 4. So they should be able to answer the question like how many 250 cups in 2 liters. So they will be able to say 4 of the 250 cups will fill this 1 liter container. And you can go on and ask them all the questions as well. For example, I have here, you can ask them, okay, 1 liter plus 1 liter, and they all know that 1 liter is equal to 1000 milliliter plus 1 more liter, which is also equivalent to 1000 milliliter. So they will be able to add the two of them. So 1000 milliliter plus 1000 milliliter.
Here we have an attribute logic set, which is a valuable manipulative used in teaching mathematics through grades 1 to 4. It consists of various shapes that differ in attributes, such as color, shape, size, and thickness, allowing students to explore classification, sorting, patterning, and logical reason. So here is a closer view of the attribute logic set. So we can use it in grade 1 to sort and classify. We can sort shapes by a single attribute, like for example color. So we have a yellow color here, a yellow shape, and we could sort another
sort them by another yellow color. So we have two colors here. And we can also sort them by shape. So we have another shape here. So if we want to sort it by shapes, we look for another shape that has the same shape as this rectangle. So here we could sort by color, and here we sort by shape. For grade 2, we can have pupils find a block that is the same shape but only small in size. So we have a big blue circle here. So we want the pupils to find the same shape but smaller in size, and the small shape need not to be the same color as a large circle. So we could find another shape here smaller in size as a circle. It is the same shape but it has a different color, and it is also different in size, whereas the blue circle is larger and the yellow circle is smaller. For grade 3, we can discuss how the blocks are alike and how they are different. For example, we can hold up a square attribute block. So here I'm holding up a square attribute block. We could ask how many sides does this block have. It would have 1, 2, 3, 4. 4 sides. Are all the sides the same length? Yes, a square has equal lengths. The third one we could say is, what do we call the name of this shape? And they would say a square. And it may be done for all other shapes. For grade 4, we can have advanced sorting and relationship. We can classify using 3 or more attributes. We could use an example like solve logic problems, like the example would be all blue or circular shapes go in set A unless they are thick. So we look for all blue or circular shapes and put them in set A or put them aside unless they are thick. So we would look for all the blue shapes or all the circular shapes. That would be all of these here, the thin ones, and the thin one would remain. Since we don't want the thin ones, we would take all the circular ones and the blue colored ones. So here we have a set with blue shapes and circular shapes, because the problem was to have all blue or circular shapes go in set A. So this is set A. We have blue and we have circular shapes here. The goal of this would be to develop critical thinking and prepare for formal logic and set theory in upper grades. And we could do different examples. We could do all red shapes go in set B, or all the thin shapes go in set C. And it would have a lot of different activities using the attribute logic set.
This model is called a 1-meter trundle wheel. Now, a trundle wheel can be used to teach measurement in mathematics, and some of the concepts that it can be teach are distance, estimating, and perimeter. At grade 1 level, it can be used to teach distance. Pupils can use the wheel to roll it on the ground and measure the distance around a shape or an area, and each click represents 1 meter. So it can be used to teach long distances, and pupils can learn the concept of measuring distances. Also at grade 2 level, it can be used to teach estimating. Pupils can make estimation and use a trundle wheel to confirm their if their answers are correct. Also at grade 3 level, it can be used to teach perimeter. Can be used as an introduction or
to reinforce the concept of perimeter.
That is grade 1, grade 2, grade 3, and grade 4. So I'll now move into grade 1's activity, which is more and less. So I'll place my objects in this container. You have 3 balls over here and 2 balls over here. So which one have more? If you look carefully here, you can see which one have more, because the one that have 3 balls inside, it is down, which is it's showing that it is heavier than the one that have 2. Right? So this one here has more and this one here has less. All right, so that's for grade 1. We'll now move on to grade 2, where is addition. So I place my container over here at 2, and then I'll place the other container at 2 also, and I'll put my addition sign. So I have 2 balls over here, and I have 2 balls over here. And if you look carefully, it is balanced because both container have the same amount of objects, right? So what we'll do now, we have 2 plus 2. We can take out the objects and count them. 1, 2, 3, 4. So we can count them one more time. 2 plus 2 is equal to 1, 2, 3, 4. So we can say 2 plus 2 is equal to 4. We'll now move on to grade 3, which is mass. That is heavier and lighter. So I have 4 balls over here. 1, 2, 3, 4. And I have 2 balls over here. 1, 2. If you look now, you can see which one is heavier because it is showing the one that has 4 is heavier than the one that has 2. Right? So we call that mass. For grade 4, we look at a little scenario about a boy called Josh, and we'll teach measurement using this mathematical balance. So it says Josh walked 6 steps from his desk to the cupboard, and then he walked back the same amount of distance from the cupboard to his desk. So we're gonna count here how many steps Josh made from his desk to the cupboard and from the cupboard to his desk. Let's go. 1, 2, 3, 4, 5, 6. And then he walked back the same amount of distance from the cupboard to his desk. Let's count. 7, 8, 9, 10, 11, 12. Right? So in total, Josh took 12 steps, because if he took 6 steps to go from his desk to the cupboard, and then took 6 steps from the cupboard to the desk, and we put them together, we get 12, right? So that is for measurement.
I will be teaching you a fun and interesting game you can incorporate with your children during your mathematics lessons. So this game is called the bingo game. So how do we go about playing this game? Say for example, I am teaching grade 2, right? So we have 3 addition sums and 1 subtraction problem, right? Good. So say for example, the children complete all the sums and they get all the sums right. So 2 plus 2, 4, right? Circle it up. 2 plus 2, 4. 3 plus 5, 8. 4 plus 8 is equal to 12. And 11 minus 1 is equal to 10. So one of the sums will be the distractor. The only way for them to get bingo is if they get all the sums correct. Right? Good. And And additionally, to help them, there we have a number line at the top. So say for example, you want to add 2 plus 2. The child will move 2 places, beginning from 2, 1, 2, so 2 plus 2, 4. You also have counters, in case the children are acquainted with using manipulatives and so in order to work their problems, right? So 2 plus 2 will give me 4. Right? So this is a very fun game you can incorporate with your children. You can use this game to teach any grade, right? Yeah, so this bingo game can be used to teach the 4 different operations: multiplication, addition, subtraction, and division. Let us do another example. Good. Let's say for example I'm teaching grade 5. I have 2 multiplication problems on the board and 2 division problems on the board. So for example, 7 times 2, right? I can use my number line or I can use my counters. Right? So let us use the counters. So 7 times 2 is same as we group in 7 2 times. Right? Good. So 1, 2, 3, 4, 5, 6, 7. Right? So we have one group. 1, 2, 3, 4, 5, 6, 7. That's 2 groups. The 2 sevens will give me 14. Right? 2 sevens will give me 14. Right? 9 times 2 will give me 18. Right? Good. So next we have the division. 16 divided by 8 will give me 16 divided by 8. I can use my counters also. So a count of 16 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right? And I group it into 8s, right? Good. So I will get 2 groups of 8. Right? But remember, this is the distractor. Right? If the child should get the last sum wrong, they will not be able to get the bingo, right? 1 into 16 will give me 16, right? So in order for the children to get the bingo, they must get all 3 of the problems correct. So the children can get their answers vertically, horizontally, or even diagonally, right? Once they get 3 answers in a row, it will be bingo.
Bingo. Bingo. Bingo.
In concluding, we can say that manipulative teaching aids promotes learning and help children understand concepts better in a mathematics classroom. Thank you.